Section 4.1, Historical Numeration Systems. A numeration system is a way of symbolizing and working with the counting numbers. Various numeration systems developed over many thousands of years and were used by Sumerian peoples, Egyptians, Babylonians, Greeks, Romans, Chinese, Hindus, and Mayans. We use the Hindu-Arabic system of numeration. Early Egyptian system, they used simple grouping. The number 1 was represented by a stroke, the number 10 by a heel bone, 100 by a scroll, 1,000 by a lotus flower, 10,000 by a pointing finger, 100,000 by a burbot fish, and 1,000,000 by an astonished person. Symbols represent powers of 10 from 1 through 1,000,000, and it is a base 10 system. 1, 10, 100, 1,000, multiplying by 10 each time. Write the number below in Hindu-Arabic form. Take a look at the number of strokes. There are 6. Heel bones, there are 2. Lotus flowers, there are 4. Pointing finger, there is 1. Six for the lotus flower, 2 for the heel bone, 0 for the scroll, 4 for the lotus flower, 1 for the pointing finger. The number is 14,026. Example 2, write the numeral 14,026 in Egyptian form. Looking at the chart first, start with the strokes. There are 6 of them. You would make 6 strokes. The number in the tens column is 2, so 2 heel bones, 0 scrolls, 4 lotus flowers, and 1 pointing finger. Example 3, complete the addition problem. Okay. Let's first look at the strokes. There are 7. Heel bones, count them. There are 11, so we do need to regroup. Add 1 to the scrolls. So make another scroll over here. And we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 heel bones to make that 1 scroll. There is 1 heel bone left. We now have 8 scrolls and 6 lotus flowers. If you're writing that number in the Hindu-Arabic form, it would be 1,817. Complete the subtraction problem. Here is our table. 4 scrolls, 4 heel bones, and 7, oh, I'm sorry, I read it wrong. 3 scrolls, 2 heel bones, 2 strokes, subtracting 1 scroll, 1 heel bone, 5 strokes. Our strokes, and I'm sorry, our scrolls and our heel bones, we can subtract. We need to regroup so we can subtract our strokes. So writing it with the regrouping, we still have 3 scrolls, but now we only have 2 heel bones, and we added 10 strokes. Subtracting the 1 scroll, the 1 heel bone, and the 5 strokes, our answer is 2 scrolls, 1 heel bone, and 7 strokes. That number is going to be 217. Ancient Roman system. Many of us are familiar with this because of Roman numerals. The symbols, the I represents the 1, V represents 5, X represents 10, L represents 50, C represents 100, D represents 500, M represents 1000. The additive and subtractive features of Roman numerals. In addition to symbols for 1, 10, 100, and 1000, extra symbols are used for 5, 50, and 500. Extra symbols allows for less repetition within a numeral. A subtractive feature was introduced where a lesser valued symbol placed immediately to the left of one of greater value meant to subtract. I preceded only V or X to make 4 or 9. X preceded only L or C to represent 40 or 90. C preceded only D or M. Multiplicative features. A bar over a numeral meant to multiply by 1000. A double bar meant to multiply by 1000 squares. 1000 squared. That is by 1,000,000. Our number and our numeral. Our number is 7. Our numeral is VII. Number is 14. Our numeral is X for the 10, IV for the 4. 60 is our number. Our numeral is going to be LX. 50 plus 10 is 60. 75, LXXV. 35,060. Remember, putting the line over the numeral means to multiply by 1000. XXXV, all with a line over it, gives us 35,000. LX gives us the 60. 8 million. Remember, 2 lines means to multiply by 1,000,000. So we can go ahead and just make 8, which is VIII, and then put 2 lines above it. Here's the classical Chinese system multiplicative grouping. Go ahead and fill the symbols in your chart. Features of the Chinese system. A single symbol rather than a pair denotes the number of ones. The multiplier is written, but the power of the base is omitted. In the tens pair, if the multiplier is 1, it doesn't need to be written. For missing powers of the base, the following rules apply. When a particular power of the base is missing completely, the omission is denoted with the 0 symbol. If 2 or more consecutive powers are missing, just one 0 symbol denotes the total omission. The omission of 1s and 10s and any other powers occurring consecutively at the bottom of a numeral need not be denoted at all. Express each Chinese numeral in the Hindu-Arabic system. So looking at letter A, look at them as pairs. The 3 lines is the 3, and then that second symbol is the 1,000, so it's 3 times 1,000. And then we have the single line, and then the 100, so that's 1 times 100. We have the 6 times 10. And then we have the 4. So 3,000 plus 100 plus 60 plus 4. The number represented is 3,164. Again, look at them as pairs. Looking at letter B, 7 times 100. Zero times 10. 3. Our number is 703. Letter C. Find your symbol. It's 5 times 1,000. And 0. And 9. The number is 5,009. Letter D. Look at the first 2 symbols. 4 times 1,000. Our second symbol, our second group of symbols is 2 times 100. That's it. Our total is 4,200. Write a Chinese numeral for each number. For 814, you're going to need the symbol for the 8 and then the symbol for 100. You need the symbol for 10 and the symbol for 4. For the number 5,090, you're going to need the symbol for 5 and the symbol for 1,000. Then the symbol for 90 is going to be 9 times 10. We do need to put that 0 symbol in there for the 0 in the hundreds place. That is section 4.1, Historical Numeration Systems.